Okay, excellent. So what I'm going to be covering today is going to be the idea of clustering. Okay, so last week, basically, I gave you some introductions to the idea of classification. So for you to be able to classify a data set, you know, it needs to be already clustered, right? So, for example, we noticed that like we could have had a data like let's just say we have two rows of data, so sorry, two columns of data basically, and multiple rows, whatever. Let's say this is something to do with, I don't know, whether the guy pays his debt back or whether he's gonna have a car accident or not. It doesn't matter. So there is a X and a X2 or XY or whatever you call it, X2, and this is the outcome basically, yeah, or class based. Let's call it the class of it, yeah. So I don't know, you had like a student having two input parameters, and whether this student is a good student or a bad student, if this customer is a car buyer or is not a car buyer, whether this is I don't know, like data about a cell, whether this is a cancer cell or a healthy cell. Okay. So we touched on the idea that when we have a data like this, we can use certain algorithms. As an example, I introduced you to the KNN, K nearest neighbor. We can use models or algorithms, machine learning algorithms like that to train or model to be able to classify data once it's trained on part of the data. Yeah. So what I thought I would get you introduced to this week is how about this? What if we don't have that? Okay. What if we don't have this? So let's say let's play a game together. Okay. And in fact, I'm going to use this game so to code as well so that you have a better grasp of the idea. So let's say we are aliens, yeah, and we arrive on Earth. And as we arrive on Earth, we have absolutely no idea of what these creatures who are humans, basically, what they are. Okay? So we send one of our agents because we have no knowledge of these creatures, these humans, yeah? We're going to say, okay, go and pick out some of these humans, check them with a camera or something, and measure their height. So our alien agent basically goes, without other people seeing it, and starts measuring a few people's heights. Yeah, so he starts measuring maybe from 150 centimeter all the way to 20 centimeters. Sorry, 200 centimeters. Yeah. So he goes and measures a group of people, a group of humans with this range of heights. Okay. So there is tons of data points, right? He comes back to us and it's like a number line. And he says that, all right, well, I went and I measured, I don't know, a sample of 1 million people and I measured their height and this is what their height was. And cool. So, but we have no idea they are women, men, they are nothing. We just know they are these creatures walking on two legs, they have two hands, and we have a parameter of height basically ranging from 150 to 200. Is there any way that these aliens can classify these humans? So, like if you want to classify them, you can classify them as, okay, let's say the aliens say that we're going to classify them as sort of short, medium, and tall, okay? Because that's their understanding at the moment of. So they're like, yeah, shall we go and, based on the data of height that we have got from these, somehow classify these humans into three sectors. Yeah, would that work? Okay. Uh, just think about that, and this is the simple example I will use when I sort of start coding. If we take it out of this context and think about something else, yeah. Let's imagine this time we have a data set of, uh, a group of, uh, I don't know, let's say sample of diamonds, yeah? These diamonds have, let's say, a factor of x1, a factor of x2, and a factor of x3, okay? And we want to see if we can classify these into like really good quality, bad quality, super quality, yeah, or maybe even more. We don't even know. We are not even sure how many classifications should we be making. How many classes can we extract out of these? Yeah. So the idea of clustering is when you have a data set which has multiple, let's say, or even a single column of information, but you have no knowledge of where does this lead to, okay? And you want to see if based on that data you can classify your sample pool, yeah? And there are various algorithms that you can use, but one of the most known algorithms is the k-mean clustering algorithm, okay? The k-mean clustering algorithm can be used for this purpose. But what does this k-mean clustering algorithm mean? So for ease of our understanding, let's go back to our case of the alien, like measuring some humans. So let's say these aliens basically get these humans that they have measured and they put them on a number line, okay? If I just put this transparent selection, yeah. So we're gonna just bring these and let's say the heights that they have had. I mean, that alien agent who went and measured human heights went and measured 9 people. Okay? I mean, we're making it super simple. Okay. And he comes back to the alien boss and says that, look, I went and measured the heights of 9 human beings. Yeah. And there were like 150, maybe this guy was 155, and this one was 160. Then I had like one guy who was 170, 172, 175, and then I had these other three who one was 180, one was 190, I don't know, one was 200 centimeter. So if it comes with a cluster, with a data points, a single number array, yeah? So number array is like 150, 155, 160, 172, 70, 175, so that's 175, and 180, 190. Like, if you put it on a number line, you don't even need a computer, do you? So straight away, you would be like, okay, that sort of indicates we have three groups of heights, yeah? Uh, so you go like, all right, I'm going to just straight away classify them into short, medium, tall. Okay, for example. But what if, let's just get rid of these numbers at the moment. We don't care about the numbers. What if, uh, you know, you have like sort of, these data points in between as well, which you will have, in fact. Yeah. I mean, let's say you're having data points like this. How are you going to, go by classifying these? All right. Obviously, when as a human you look at a small data set, as I said, just like before, when it was simple, you could you could sort of guess and come up with a solution that, okay, this was one group, that was one group, that is another group. But if we are now going to use a computer model, we're going to use an algorithm to achieve this, we need to be able to tell the computer or write the program such that it can go and basically, do this without the vision that us humans benefit from. And to do so, it needs to go and start working with data points and measuring distances, right? The way the k-mean clustering algorithm works is that it goes through by randomly, for example, when you decide to divide this into 3 points, yeah? The way it works is that it first comes and creates a purely out of guess, yeah? Purely out of guess. It would come and choose because we want to cut these into 3 groups, yeah? Okay, so let me just bring these because we want to select 3 groups. Okay, so we're gonna go, sorry, excuse me. We're gonna go with 3 groups and we're going to just randomly just place these somewhere. Absolutely randomly. So the computer is going to be just randomly selecting 3 points. Okay. Then what it's going to do through the algorithm, it's going to measure the distance between every single point and this random point. Okay. So it will be measuring all the distances. Okay. Then it will choose. So I'm oversimplifying it at the moment so that you understand the point. And it's going to associate this one with this because they're closer. Okay, let's say. And possibly go like that. So it's measuring these distances. Okay. If it is, I mean, let's think about it logically, yeah? If it is to classify these perfectly, the idea, the idea is to minimize the distance of each point to the randomly selected point, okay? Minimize the sum of these distances, minimize the sum of these distances between each random chosen point and the associated cluster with it, while reducing the variance, okay? Reducing the variance, and at the same time have maximum separation between the clusters that are, like selected separately. Now, what it would do, technically speaking, I mean, like I just showed one process, and I just chose this one to be the brown ones, this one would be the green one, and this one would be the blue one. And we chose 3 because we have decided to tell our algorithm to go and divide this data line into 3 clusters. If we said go and divide it into 5 clusters or 2 clusters, then those random initial points would start at 2 points basically. And we go through a loop constantly trying to measure the distance of closest circles to the randomly selected, like not circles, but data points, to the randomly selected point, and keep doing it until we minimize the distances here and minimize the variance between them while maximizing the distance of the other clusters. Okay? So that's what happens under the bonnet if this was a single number line. Obviously, that is if you had just one column of data. Okay? If you had 2 columns of data, it means that your data would be plotted on an X and a Y plane. Okay, so need to get rid of the, okay. So you would have an x1 and a x2, okay? If we were to sort of have two features, then you would have these points scattered across. Let's just do it. So, so this time, instead of having these points on a number line, they would be sort of, like once you plot them, they're going to be sort of scattered like this. I'm just going to separate them, like distance them from each other so that it makes a sense. And just like the previous time, when you want to create, let's say you got 6 data points and you want to create, okay, let's just say, since we went with three, let's just go with three, isn't it? Let's say we just want to cluster these. The same way, exactly the same way, you would be choosing, again, random points to start with. And this is like the brown one. And you place it here and you measure the distances. You place it here and you do the same with the green and the blue, yeah? And exactly what you try to do here, minimizing the distance and the variance between clusters, sorry, within clusters, and maximizing the distance between separate clusters, except that you do it with in the two-dimensional space. And last week already, well, previous weeks, I introduced you to the idea of Euclidean distance. And I can't, we don't have time to go and cover that again. And you use the Euclidean distance formula to measure the distance of each point to the other point. Yeah. So at its core, that's what the k-mean clustering algorithm does. Okay. So have the idea in your mind, but ultimately, I'm not so much bothered about you guys at the moment getting fully right away grasping the idea in like 1 hour. But just know that k-mean clustering is used when you have a certain number of data inputs, okay, like customer heights, customer weights, yeah, or person's height, person weight, and nothing else. And you want to see if, without knowing anything else, you can cluster or group these individuals based on those data that you have, yeah. Unlike logistic regression, I don't know, linear regression, well, or like k nearest neighbor classification, which you already knew, like the guy wants to buy the car or he doesn't buy the car from previous data, past data, that you trained your model. In other words, your model was supervised. It knew the outcome on the training data. Yeah. So you trained it on training data, knowing the outcome, and then you tested it on data that you didn't let it know the outcome, and you wanted it to see if it predicts it right. So that was supervised. In this case, because we don't know if our data has a class, what classes it belongs to, if there is any sort of subclasses in it, we have no idea. We just have input information. This is referred to as an unsupervised algorithm. Okay? And that's the tricky bit about it. It just helps you to cluster the data. So it's an unsupervised machine learning model that we're going to be doing, right? So having said that, just to get things a bit exciting, let's go and start working with Python, yeah? And we're going to see how this is going to play out. So mainly I want you to become comfortable with the Python bit, yeah? But then gradually you will grasp the idea. So let's start. I'm going to say import numpy as np, import matplotlib.pyplot as plt, and from scikit-learn, of course, this is a new one, I guess, for those of you who haven't seen it before. So from sklearn dot cluster, okay, import K, capital M, min, and that is it. So far, so good. We imported the necessary libraries that we want to sort of work with, all right? And just so that while you're coding with me, you're having similar data to me, we're going to just set a random seed in the next cell when we generate the data. Let's just work with customer, I keep saying customer, the human heights. Let's say we are these aliens and we are just bothered with the height. That's the only data we have from these humans. So np dot random dot seed 42, okay? And I'm going to say heights, yeah? So heights equals np dot random dot uniform distribution, uniform, right? Let's say we're going to go from 150 centimeter to 200 centimeter, 2 meter tall, and we want customer 100 human samples, not 1,000, 100 human samples. Okay, that's our data. We are assuming that our alien soldier or whatever went and collected this much data from these humans. Let's take a look at it. So height, okay, that's it. That's all the data we have. So he has gone there. Some guy was 168 centimeter, another one 197, one was 152. And we don't know as aliens what does this mean. We just know this is like the height of their body. We want to see if this is good enough to cluster these humans into subdivisions. Maybe they are looking at us as ants or something, and they want to see if they can figure out if we have a worker class, we have a queen, and then we have like soldiers or workers or I don't know, males or whatever. They just want to explore us. And the only feature data they extracted at the moment is the height. Okay? And they're going to run an algorithm and try to see if they can classify us to something. So they sit down together and they say that, well, maybe in their society they are comfortable with, like, they have three classes of individuals, yeah, just like ants, like there is a queens or there is soldiers and there is workers, and they're like, okay, let's go and see if we can classify them into three groups. So by purely instinctive idea, they choose number three. Okay, so they're gonna try and cluster these into three groups. Yeah. So now that we have imported k-means, we're going to say model, yeah, or model, or whatever name you want to give it, but model is a cool name. Model equals k-means. So I'm making an instance of the k-means class, yeah. Number of clusters, and we said that the aliens want to choose three, yeah. You could choose four, you could choose five, you could choose 10, you could choose anything. Well, obviously, it needs to be sensible. But let's say we go with the idea of three for the moment. And let's just say random state equals 42. Now, why do I use random state here, guys? I don't have to, but why am I using it? If you remember, I said that when you want to start this algorithm right from the beginning, when you start setting, like those three colored points that you choose to suddenly try to create clusters, you choose it randomly, isn't it? Then you start measuring distances. Then you keep changing these random positions and try to minimize the distance within the clusters and maximize the distance between clusters. That's what the algorithm is trying to do. So because that's a random event, when I say random state equals 42, it's so that if you are doing it with me, you would get a similar result to me. Otherwise, you don't need to do this, yeah? So just bear that in mind. So I'm going to make an instance of the k-means class. I'm using number of clusters equals 3, and I'm going to name my model. There we go. So model made. We have a model ready. Is it trained? No. Has it seen any data? No. Okay? So we need to train it on or basically model. What do? Super simple. We're going to say model dot fit, and I'm going to fit it, and I'm going to give my height. Yeah, my heights data. But I assure you that I'm going to get an error. Okay, so let's just do it. So let's see. Our data perfectly is in there. We're going to have our k-mean clustering model, which already the algorithm is written for us. And thanks to scikit-learn, we don't need to write the whole thing. That's it. We got our model. So we're going to feed the data into it, but we'll get an error. Why? Let's look at the error. But can you turn off your microphone, please? Yeah. So what does the error tell us, guys? Let's see. Reshape your data either using array.reshape if your data has a single feature, which is our case, or only feature is the human's height. Yeah. Or array.reshape 1 minus 1 if it contains a single sample. All right. That is if you're like using a single number line, but number point. But forget about that. We're going to go with this. In other words, if I say heights.shape, you will notice, look, it's just a single number array. Okay. These machine learning models, they like to have put it this way, you want to put a vector in there, a single vector. All right. So we need to just define the shape. Okay, so what we're going to do first, we're going to say heights reshape equals heights dot reshape and minus 1 1. Okay, this is now going to make it look like as if it's a single column. Okay, so that's what it does. Now if I say heights dot reshape dot shape, yeah, so that we see the shape of it. As you can see, now it's like a single column. Yeah, it's like a vector now. Okay, and these machine learning models usually like the data to be in this format. Nothing is changed. It's exactly the same numbers. Everything is the same numbers. It just is the format of the data. It's in form of a vector. So if I say heights reshape, okay, so now I'm going to fit my model onto the data. Yeah. Let's do it. There we go. Our model just got trained. How did it get trained? Again, reminder, back to the first example I made you with them three colored circles. It just made tons of those random, like colors, put them in different positions, and kept measuring and trying to create clusters out of it. That's all it did. But obviously, it did it in a split second. That was thousands of calculations that was just carried out. Now our model is trained. Yeah. Or unsupervised model is trained. Yeah. And out of its own sort of its own merits, it has gone and tried to separate our data into three different groups. Okay. And now that it's done, shall we see if it has decided anything? So I'm going to call one function out of this. Yeah. If I say my model is trained. Yeah. My model dot cluster centers. Yeah. Let's see what do I get. Okay. You know those colored lines basically that I showed you. Yeah. This is basically, it's like as if he has gone and has decided finally, after choosing different various combinations of brown, green, and blue, doing loads of calculations, trying to minimize the distance between clusters, maximize the distance uh, between the clusters. He has come up with a final decision. Yeah. And when you say cluster centers, it's the final green, brown, and blue that he has chosen. Okay, that's what that means. All right. So when we call model.cluster centers, it just goes and picks them out. Why is it three of them? Well, because we asked it. We said go and fetch three clusters. If I had put four here, it would try to cluster the data into four groups. If I had asked it to do five, it would try to do the exactly the same thing, but with five basically data points. Yeah. Okay. Now, fine. It has chosen those center points, what did I use, guys, for the? I mean, this is 0.156191172. Yeah. When I was showing you that picture, that graphics, I used the word brown, green, blue. Okay. But obviously, it doesn't go and cluster them into brown, green, blue. It associates a number to them. So it's three numbers. So it's going to be class 0. The world in Python starts from number 0. So he has clustered them into three groups. Group 0, group 1, and group 2. Okay? Three groups. So if I say model dot, no, model dot labels. Yeah, these are the labels that he has associated them with. Yeah, let's just run that as well. There we go. So after 100 data points, yeah, after 100 data points that we gave it, these data points, he has gone, created three clusters based on these cluster centers, and has classified them as such. Okay? And he has just classified them as such. Now, shall we go and just visualize this? Yeah, try to see if it has what does it look like? You know, how these number line, these heights that we measured, like how do they look like? So let's use matplotlib visualization. plt.scatter. Okay. We're going to plt.scatter. We're going to do heights. We're going to do how many we need np. All right, let's make let's do this np zeros like, and how many of these do we want? Of course, the same number of so heights. Okay, and then we need to label these, right? We need to color them. We need to color these based on our labels. So C equals our labels. So it's going to color them when it plots them based on these labels. Okay, did I put the label correctly? Label. Oh, wrong. I just realized I forgot doing something. So model.clusters gave this to me. What I really need to be sort of associating this with something. Yeah, so I'm going to just call this center sense. Yeah, and I'm going to put, and I need to run it. So sense is just those three cluster labels. And then let's just call these labels, label. Okay, so that's it. Like instead of just anywhere. So based on those labels, we're going to do that. Maybe CMap user plasma or something. Plasma. And then marker, let's have it as a circle or a dot or something. And how big should the size be? Size of it. Let's just. I'm going to choose size of 20 for those dots just to see that it all comes out okay. Yeah. Okay. Heights. Yeah. Let's just do that. That's our number line. Okay. So that is our number line that the alien, went and measured from 150 to 200, and our algorithm has classified it like this. Shall we also see the number lines? Sorry, the centroids, yeah, that we create, the centroids, these ones. Let's plot those as well, the cents, yeah? So if I say in the same cell, plt.scatter, and we're going to scatter the cents, which are three of them, and if I go with scatter cents, think, just give me 1 second. All right. That's not a good. Let me just increase. Don't worry about this last bit, this bit of code. I don't care like so much about it. I only want you to. I hope that's not too big. Okay, cool. Yeah. So the idea is that we had this number line, or algorithm went in there and created, after going through and selecting three different random points over and over and over and trying to sort of create three clusters, it came up with these three clusters. These are the centroids, the crosses, and these are the classes. So the aliens can now say, okay, based on height, we can group these humans into three sectors. Does this mean anything? Well, because we know, no, you cannot like group humans based on their height. It doesn't really give you that much information. But it's good as a start because now you can say that, okay, at least we can classify humans into short, medium, tall. Okay? So what if we send this alien agent to go and fetch another set of data, okay, from these human species? How about if we tell him you go and measure their weight as well? Okay, so let's generate some weights. These are just random stuff, yeah? Random dot seed. Let's go with the same. Spell that right here. 42. And I'm going to say weights equals np dot random dot uniform and weights, let's say 45 kilos all the way to 140 kilos and all the way to 100. Okay, we are just generating, sorry, my misspelling again. So we're just generating some 100 random weights. Okay, uh, assuming that this alien is going out there and fetching the weights of these individuals he measured their height of. Yeah, and there we go. Our alien, agent went there, came back, and he has now this data for us. Okay, so now our data is two-dimensional. Before we were only dealing with heights. It gave us that classification, but which is not really informative, but it gives us some sense of, okay, humans can be grouped into three, but somebody can always come and argue with one of four, yeah? As such, this doesn't really tell us anything yet. So we sent him to go and capture weights, and he has come back. We have more data now. So let's stack these data together, and we're going to just call it data. So we're going to say data on humans equals np dot, we want to create column stacks, yeah, put them next to each other so that these two number lines become two columns. Column stack, I mean just stack them next to each other. Heights, was it heights? Yeah. And I'm not using heights reshape, guys, yeah, because when I stack them together, it's going to have the right shape now, isn't it? Wait, so please do not get confused as into, oh, why Ali last time said you need to reshape this, but now he's just putting them in the data. But because when I'm putting them next to each other, they become like two columns, and then they are in the form of a vector sort of matrix shape, yeah? And uh, I don't need to, worry about like reshaping it. In fact, I will show you the shape of the data so that you satisfied. Data. Let's just make sure that we are not dealing with a single number line, as I'm saying. There you go. So it's 100 by 2. There is the rows and columns. It's not just 100 comma. It's two columns and 100 rows of data. Okay? So again, what do we need to do? Just like last time, we're going to define a model and train this bit. This time I'm going to call model. Let's call it model 2 equals k means, yeah, before we made the instance and we called it model, this time we call it model 2, and we're going to stick with that number of clusters equals 3. Let's just say these aliens like the number 3 for the moment. For some reason they feel that it's going to be three classes coming out of this for whatever reason. And then random state again, random state equals 42. Again, this is so that the initial random points that we choose start at the same point, basically. Otherwise, you don't really have to do this. There we go. Our model is made. Is it trained? No. It only gets trained. Let me just write this here. Is it trained yet? No. It only gets trained after we fit it to our data. So we're going to say model2.fit, model2.fit, and it's going to be data. There we go. It's now fitted on our data. So shall we go and, just the same way? All we are interested in is to find the centers, yeah, and what do you call the label associated with it. So definitely we're gonna have three centers, yeah. So centers, center, centers equals model two dot cluster centers, okay, and labels equals model two dot label. I know this is a bit annoying, this bit here, but it has to be there, guys. Yeah, you can't miss this thing. This is part of the function. Okay, so let's do that. All right, let's just look at our centers. Centers. Okay. Do you notice something, guys? This time our center before our centers was a single number. Okay. Before our centers were a single number array, three of them, because they were on a number line. This time they are coordinates of a point. Okay, so just like that, before the centers were on a single number line. So it was like, I don't know, 197 or 197 or 180 or I don't know, 156 or something. This time, because we have two dimensions, we have height and weight. Each center will have a coordinate. So you have an x coordinate and a y coordinate. And that is exactly what we see here. For the first point, x and y coordinate, x and y coordinate, x and y coordinate. Okay? How about labels? Let's look at it. Obviously, the labels should be still from number 0, 1, 2. Three classes, yeah? So if I run that, as you can see, same thing, because it's trying to classify them into three classes. All right. Let's go and now do this. Yeah. Let me see. Let's try to visualize this now. Okay. So plt.scatter data or data, all the rows and first column. Oh, sorry. All the rows and first column, okay, and then data, all the rows and the second column. That's what we are plotting against each other, and we're gonna say C equals labels. Yeah, have I spelled that right? Yes, C is basically going to color them, accordingly based on the class. CMap equals, I'm going to just use plasma. You can use whatever you want among the options. I always forget these names, they're like the color codes that you use. I think you can use heat as well, for example. There are millions of these colors you can use, but I'm used to plasma, so I just use plasma. Marker is going to be a round sort of circle. S as size equals 20. Cool. Let me just do that. There we go. Of course, in real life, you don't get this nice straight line. You get like these clusters happening. But because I want to oversimplify this for you and I've just generated data out of blue, this is only for the sake of you guys understanding and getting comfortable with the code. It looks like this. But otherwise, if you use real data, it would be blobs of red here, blobs of maybe yellow around here, and blobs of blue maybe there. Yeah. But anyway, so this at the moment is again the data are clustered into three groups. Yeah, based on the height and body weight. Okay. The aliens sit down here and go like, oh, okay, that's interesting. Again, we got three groups, but that doesn't tell us still much more information. Uh, Maybe we go and fetch another information from these humans. Okay, let's say they want to fetch something else, and they send their agent to go and get something else. And this guy goes there, looks at these individuals, and he goes like, okay, what other feature can I measure in them? And he, through his sophisticated equipment, he can measure the pressure of the blood in the human's veins. So remotely measures their blood pressure, and it's going to collect their blood pressure as well. So we're going to have a new set of data coming in from this alien agent. Pressure. So blood pressure equals np dot random dot uniform 90, 180, and 100. So I hope yeah, is it the blood pressure going from 90 to 180? I think so, yeah. Or even if it's not, just ignore my ignorance in the medical field. But we are assuming that you can have a blood pressure of 90 to 180 and 100. So for the same guys, he just goes back there. There we go. Measures their blood pressure as well. Oh, I didn't choose random seed, did I? Well, you can do it yourself later, right? You can choose a random seed or you can just not choose it. All right. So let's pack up our data again. So we're going to say data equals np dot column stack. And what we're going to do, we're going to put the height. We're going to put the weights. And we're going to put the blood pressure. Okay. So the alien agent has gone on now. Come back with a more exciting set of data for us. Let's look at it. There we go. It's like a table of numbers where you got the heights here, you got the weights here, and you got the human's blood pressure as well. All right. So a bit more interesting compared to before. And let's just double check the shape. Always I love to check the shape. Always do that. Yeah, 100 rows, 3 columns. Perfect. So we go back to our lovely model. We call it model 3, a new model, and we use it as an instance of the k-means algorithm. K-means, and then we are sticking with the number of clusters equals 3, of course, and random state. Should I use random state or not? Yeah, let's. Usually I feel lazy, but random state equals 42. Okay, and let's just fit it here as well. So model 3, no, let me not do that. Just, I'll first make my model. Okay, so my model made. Is it trained? No, it's not. Why not? Because I haven't fitted on any data. It's just built. So I'm going to say model 3 dot fit. Fitted on what? Of course, our data. And our data is in the right shape. It's in a matrix format. It has rows and columns, so no issues with that either. We do this, and there we go in an instance. It goes on now, does it in the three-dimensional space. Okay, so it's now done it in the three-dimensional space. Uh, because we have three basically inputs there. So let's go again. Centers equals, obviously I'm overriding these centers, yeah, unless I save it under some other name, which I don't care. So model tree dot cluster centers and labels equals model tree dot label. Yeah, there we go. Let's take a look at our centers again this time. I hope that you all agree that it's going to have three columns technically, yeah? Three coordinates, okay? Three coordinates. So it has created three centers in the three-dimensional space, 3D plot. So that's the height, weight, and blood pressure of the first cluster that he has generated, yeah? And he has used exactly the same thing, the Euclidean distance, to measure the distance of these points in the 3D space, all right? And labels are 2, 1, 1, 0, 2, 2. Okay. The labels obviously are going to be either 1, 0, or 2, yeah, because we have asked three labels to be selected, right? So let's go and visualize this. Okay. The visualization of this is going to be a bit different, yeah? So I write the code and I'd like you to explore it yourself. So I'm going to just say fig equals plt dot figure, okay? Let's just do, well, fixed size. You know what the fixed size does. Fixed size equals, let's say 10 by 6. And we're going to create a 3D axis, yeah? X equals fig dot add subplot. It's going to be in a 1, 1, 1 projection. You don't need to memorize these, guys. You can just copy paste it for your own projects, or like you can even, there are different sort of ways of even writing this. Yeah, I don't, you don't need to memorize. This is when you want to plot a 3D plot, you can either ask ChatGPT or you can just copy paste this. Yeah, so don't bother too much about wondering why is the case. But the ideas that I want you to understand came in clustering. Okay, so let me just see. Fig comma dot add subplot one moment project in 3D. So fig is there. All right. So we need to now create a scatter of this. X dot scatter. What are we going to scatter? We're going to scatter data, all the rows, first column, data, all the rows, second column, no, third, and data, all the rows on the final column. Number 2, again, we need to make sure we define C equals the labels. C equals plasma, and CMAP equals plasma. Size equals, 20 seem to be nice. And yeah, let's just do it. Let me just see if everything is fine. I'm not making any mistake. Should be okay, hopefully. Yeah, okay. There we go. This time, he has gone and created a 3D plot of these scatters. So we can see that he has gone and has clustered the human. Let me just make these, maybe if I make them a bit bigger, they look nicer. Or like they would look more sort of, okay, yeah. So using the human height, weight, and blood pressure The aliens have managed to, by pre-assuming three classes, have come up with this sort of clustering of the humans. All right. Now, would this make any sense? At the moment, aliens don't have a lot of information about us. Yeah, they don't have a lot of information about us. But please listen carefully to this. This is really important. Yeah, because I want you to understand and appreciate where does K-mean clustering in real practice comes into effect. So the aliens managed to get these data by assuming three clusters. They could have gone for four or five or six or seven or eight or nine or 10 or whatever. Yeah, but let's say they went with three. They have come up with this clustering technique, with these clustering groups. Yeah. Now imagine if one of the aliens who is a doctor and has other sophisticated sort of stuff says that, okay, now that we have these clusters, can you go and measure the probability or like the occurrence or I don't know, shift the time into future, see which one of these humans would have a heart attack. So suddenly an alien society that moved in watching us on the skies and we don't know about them, by collecting three data points from every human being on Earth, using height, weight, and blood pressure, has managed to create some form of profile that if further analysis and experiments are carried out, he can start to gain insight into the body mass index of a human. Like he can start to try to predict which of us are healthy, which of us are not healthy. Yeah. But obviously that goes via further sort of tests and different data being put in there and different examinations being carried out. Yeah. And that's what exactly these days scientists, in different fields or disciplines use K-mean clustering for. Okay. In fact, that's what they use it for. For example, they would go to a cave and sort of collect some form of rocks or something which have some data features into it, and they would try to see, okay, can we classify these rocks into three different groups maybe, or two different groups, yeah? And they would try to do this, okay? And uh, it's a very powerful technique when you don't know much about your data, yeah? When you don't know much about your data and you want to sort of start from somewhere, it's unsupervised, and you want to explore the data through clustering them. But hold on, two things first, yeah? So let's go back to our aliens. They're like, okay, we need to create a report for the boss, yeah? We got this. Let's go and, prepare a report. Okay, import pandas as PD because they want to make a data frame of this, yeah? Remember, at the moment, that data is like that. This is where the alien soldier went down there and measured people's sort of stuff. But then we carried out this analysis and we classed them. Now they want to add these classifications. Yeah, we want to add these classifications, create a nice looking data frame for it, right? So how do we do that? That's the pandas practice. We first create a data frame, df equals pandas.data frame, data, and then we're going to just make columns equals uh, height, weight, sorry, and blood pressure. Blood pressure. Okay, let's make that. And I made a mistake. Where did I make the mistake? Module pandas module data. Oh, sorry. Okay, so if I say df, now I have a data frame, a nice data frame, height, weight, blood pressure. And of course, we did all these wonderful mathematics to classify them, yeah? Let me get rid of this. So we want to have these classes in there as well, yeah? So we're going to say for df, yeah? So we're going to say or df, or df, let's call it class ID, the human class ID, yeah? Uh, class ID equals, of course, the labels that we, or algorithm calculated, yeah? The labels, yeah. So let's run it. And if I say df.head, there we go. So we've come up with this, okay? So based on the height, weight, blood pressure, and using k-mean clustering with the assumption of 3, again, that number 3 was just assumed, yeah? We have created, these 3 classes. But of course, you can argue that, well, is there any way that we can sort of come up with the idea of what sort of number is right, yeah? What k number should we choose, yeah? And if you remember last week, I told you about the elbow method, and in fact, we can do the same thing. What time is it? We can do the same thing here, okay? I really like you to let me prepared something so that I can copy paste it instead of let me copy paste something for you. Okay. What we need to do is to calculate the inertia and the within cluster sum of squares. Yeah. Let me write these definitions for you here. That wasn't a good idea. Uh, 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 you know what? Text. That's better. All right. What we can do to choose, like these aliens are wondering, okay, was choosing 3 a good idea? Or was it just a pure guess? Maybe really humans can be clustered into 5, 6 different sort of sects. Yeah, God knows. Um, you see, I want you to bear in mind when you're clustering them, what are you going? You see, because they don't know if they have male or females yet. They don't know much information about humans. What they have just so far collected can be interpreted into the human health factor. Yeah, blood pressure, height, weight. Maybe the guy is obese. Maybe he's too skinny. I don't know these medical terms. Yeah, um, but ultimately, you want to find out what is the right number of clusters, perhaps. Yeah, let's look at this. What is an inertia? Inertia is a measure of how tightly grouped and data points are within each cluster. We already discussed this, yeah? In technical term, it's the sum of squared distances between each data point and the centroid of the cluster it belongs to. Please take a note of this. I want you to go and read these 2 points, yeah? Because this is something you need to read and understand. It's quite simple. It's quite simple. I already referred to it in a sense. If I go back to that, look at these distances, yeah? Sum of the squared of the distances. So technically we have done this. This has happened under the bonnet when the algorithm was operating, yeah? In a sense. But I want you to explore it yourself further. And what is within cluster sum of squares basically measures the distance of each point in the data set. Please read carefully. Measures the distance of each point in the data set to the associated centroid. We chose 3 centroids, yeah? Square it and sum it. Then add the value to the same sum of the remaining clusters. So we had 3 of them, isn't it? So you measure the distance of every point to that within each cluster to the centroid that was chosen, and then you square it and you sum it with respect to the other clusters. Yeah. Well, as I've told you, you need to go and read about this. Once you're adding them together, okay, the idea is to have the lowest value. So adding more clusters keeps lowering it. So the more clusters you assume, it's going to lower this value. I'd like you to get a pen and paper and sort of practice with numbers. Just try make a mockery, just make a mocking numbers like 15 number line, 15 numbers on a number line, and try to do this by hand and feel it, see what happens. Yeah. The more clusters you introduce, you say like, oh, I want 5 clusters. You see this number keeps going lower and lower and lower. Yeah. What the idea is, let me show this to you. Let me get rid of this. The idea is this. Yeah. So this is when you want to choose, when the aliens decide that, look, maybe we went wrong with number 3. Like maybe we first should do this and come up with how many like clusters we should choose. So you can start with 1 cluster. I mean, technically, you can go with 2. You can go with 3. You can go with 4. Oh, come on. Okay, let me just. You can go with 5, you can go with 6, you can go 7, 10, blah, blah. I mean, like, go whatever clusters you want to go with, 100. Obviously, then that makes it irrelevant, isn't it? Well, you can actually go. So 100 clusters, and then you want that error factor, that value, the sum of the squared differences, yeah? Let's just call it error for the moment, okay? But really, VCSS, we call it within clusters. Let's just within cluster sum of the squares. Okay, this value within cluster sum of the squares. What you will notice usually is that obviously with 1 it would be pretty high. When you choose 2, it would be like it suddenly drops down. When you choose 3, I mean, this is an example, yeah? Let's say for one test we are doing, it goes like that. Then when you choose 4, it goes like this. We go 5, it goes like that. Okay? And so on and so forth. Yeah? Let's just say. The idea is if you run that inertia, I will show you the for loop, how you do it in a second in Python. Yeah? When you run that algorithm and choosing different k's in a for loop and measuring this within cluster sum of squares, you get a plot like this. Yeah? So if I get this pen, it goes like that. The golden rule is this. You choose the point where you get this massive sharp sort of depreciation stopping, which is around this point sort of. That's why it's called the elbow method. Yeah? The point where the elbow forms. The moment that acceleration in lowering of the within cluster sum of squares slows down, you can consider that to be a good number of Ks for your clustering with your data. All right. So how do we do this? I've prepared this so that I can just do it and we can end the class. Also, when you practice with this later, let me just double check that I've put everything. So elbow method, WS, WCSS, so that, yeah. All right. Do you see this thing? K means not inertia, okay? Let me change this because I think that may sort of confuse some of you. So go away. All right. So I'm choosing an empty list. Okay. I'll call it, well, you can call it error if you want. Yeah. Whatever you like to. But it's that, what we just discussed. Yeah. Within cluster sum of the squares. So I'm going to go, the aliens, let's say, they want to say, okay, let's check from 1 to 10 clusters. We chose 3. Maybe that was a crap idea. Let's try to see which number is good. Yeah. Okay. So, sorry, can you turn off your microphone, please? So, model, we are creating a for loop. We're creating an empty list first for k in range 1 to 10. Yeah. Obviously, it's going to be 9 of them. Model equals k means number of clusters equals k. We already done this, guys, except that we chose 3. This time we're going through a for loop and we're going to update it. Model.fit the data and wss.append model.inertia. What is inertia again? Inertia is a measure of how tightly grouped the data points are within each cluster. In technical term, it's the sum of squared distances between each data point and the centroid of the cluster it belongs to. Please make sure you understand this, yeah? And then we measure the model's inertia, add it there, okay? In other words, the error, same thing that we discussed. Once we have done this, yeah, we are going to plot it. We're going to plot range 1 to 10, numbers 1 to 10, against the values that are accumulated here. We put this title and X label and Y label. These are just the labels of the data. Let's do this, and you get that. Okay. Now you might be like, oh, Ali, so does this mean number 4 is good or number 3 is good? In reality, because I generated my data randomly, okay, this doesn't really make much sense. But in a sense, you can say that, yeah, number 3, number 4 looks like to be the good choice for a cluster, okay? Definitely number 1 is not, because who does it? I mean, who would cluster something as number 1? But there are instances that you would do number 1 and you see that, oh, when you run it, instead of going down like this, it's going like that. Maybe that indicates that you're all, I don't know, your data really is not that different from each other. But you rarely get that. What you try to do is to first do this and try to choose the elbow point and you go with it. So everything we did so far, in future when you want to do k-mean clustering for your data, you need to first run this. Obviously, I showed you doing, choosing number 3. That's because I wanted you to learn the concept, yeah? But in future, when you want to cluster your samples, cluster your data, create clusters out of it, you first run this for loop. You generate this elbow plot for your data. You choose the elbow points and you carry out with your experiment with that number of Ks. That gives you a better, more sort of accurate outcome if you choose the K value rightly. And this is the way that you choose the K value. Uh, well, I hope you have enjoyed it, guys. But again, I try to cover like really exciting and big topics in very short time. So I apologize if you sort of feel that, okay, we rushed through this, but there is no other way. But I'm sure you're all clever. You can go and now expand further on it, go in and start doing resources on the internet. There are many guys doing great YouTube videos basically on these. There are stuff on the internet that you can read, and definitely try to learn this algorithm and understand it. Doesn't matter if you're from engineering background, medical background. This is one of those techniques that it will be so useful in your future career for you. Yeah, it's fantastic. Okay, what time is it? Again, I didn't finish on time, so let me stop this. All right, so I'm gonna stop the video now.